Hi, so welcome back. So in this video, I'm going to finish describing or identifying the key behavior of the polynomial. Okay, so here in my previous video, I stopped at the factor form. So now we're going to continue and write the standard form. Okay, so the standard form is going to be, so to get a standard form, which means you want to see every variable x, and the exponent of the variable x is going to be ordered in descending order. So first, what I want to do here, I'm going to multiply both to the last two factor, the two factor on my right. So x plus 3 times x minus 3. So you can use the distributive property or the box method. So I'm going to use the box method here, okay? So you're going to multiply. So x plus 3 and then x minus 3. So x times x is x squared, x times negative 3 is negative 3x, and 3 times x is going to be 3x, and 3 times negative 3 is negative 9. Now, I hope you can notice here that the middle term can be simplified or can cancel out because they are opposite of each other. Negative 3x plus 3x add up to 0. So the product of those two factors multiplied to x squared minus 9. So then the standard form is going to be y negative 2 times what? X squared minus 9. And since you have only one term here, what I can do is to distribute one factor, okay, one number for the factor. I can distribute a negative 2. And I end up with y equal negative 2x squared minus 18. And here is the standard form. Again, it goes from descending order on the exponent. So we start with exponent of 2 to 0. And again, what is going to be the vertex form? So the vertex form, I can use y equal to the a times x minus h, everything squared plus k. And remember, so what is hk? Hk represents the coordinate of the vertex. Okay, since you have a parabola, you refer to it as vectors. So the vertex, the coordinate of the vertex here is 0, 18. So what am I going to do next? I'm going to replace h with 18 and k with 0. So the vertex is going to be y equal, and don't forget that we already found a to be what number? We found a to be already negative 2. So you're going to replace a with negative 2. So you end up with x minus, h is 0 minus 0. Sorry, I say 18 squared plus k, and k is going to be 18, positive 18. So if you want, you can continue and rewrite it as y equal negative 2, okay, x squared minus 18. And the reason is because x minus 0 is x, and you square it, you get x squared. And you have negative 2 plus 18. Oops. Which is the same as the standard form, and the reason is because the middle term is cancelled, is 0, is 0x. So what will be the domain? The domain, okay. To find a domain, you want to look at what are all the x-axis, right? What are the possible x values of this polynomial? And I want you to look at the graph of this polynomial, okay? This is a parabola. You see how the line is continuous, right? There's no gap, there's no break. So the line continues all through, okay? So because the line is continuous, it tells us that x can be any real numbers, and that's true. X can be any real number. It can be negative 1,000,000,000. It can be positive 1,000,000,000,000. It can be a fraction, a decimal, the square root of negative 5, or square root of positive 5. So this domain can be x can be any real numbers, okay? And I'm going to use a domain interval notation, and you're going to start from negative infinity, comma positive infinity, and use parentheses. Only use parentheses on infinity because of the definition of infinity. It means that the x value keeps on positive infinity means the number keeps on going forever, and then negative infinity means the number keeps decreasing forever. And you don't want to stop the expansion by putting a bracket. So that's why you always use parentheses, okay? And what else I wanted to say about the domain? Yes, polynomials. Okay, polynomials. We always have. We'll always have what? Always have the set of real number. Okay, as the domain. Okay, so for any type of polynomial, the domain will always be all real numbers. Okay, it will be all real numbers. Okay, it only works for the domain. Now for the range, it depends. If the range is odd, if you have an odd degree polynomial, the domain will also be all real numbers. But because here you have is even degree polynomials, so to find an even degree, always start with the lowest y value. So always start from the bottom up for the range. You always look bottom up. So the lowest y value, we start from the bottom. So we go from negative infinity, parentheses on it. Okay, and the highest y value that this polynomial can be or can have, the highest y value is going to be positive 18. And bracket or parentheses are 18 because the y can be 18, right? We have y equal 18. Remember, this is x and this is y. Y is equal to 18. That's the coordinate of the vertex. So yes, so because 18, the y value can be 18, you use a bracket like that. Okay, and we are done identifying the key feature of a polynomial by using its graph. So thank you for watching my video. In the next video, we are going to do number 6. Okay, so thank you. Have a wonderful day and see you into the next video. Bye-bye.